Welcome to Ecoholics YouTube channel. So today we would be discussing about a previous year question from the exam IIT JAM which was conducted in 2023. So the question number is 33, which is an interesting question regarding the Nash equilibrium. So in a 3-player game, so there are 3 players, player 1, player 2 and player 3, and each of them have 2 strategies to choose. For player 1 it is up and down, for player 2 it is left and right, and for player 3 it is either table 1 or table 2. So you are expected to find the Nash equilibrium or Nash equilibria. So which of the following strategy profiles is or Nash equilibrium? So you will not know whether it is 1 or 2 points unless until you are going to solve this. So how to solve about this particular question? So given this table, so you have player 1, player 2, player 3. Each of their strategies and their respective payouts have been given here clearly. So how to go about solving this? So first we have to understand the optimal strategies for player 1. So the optimal strategies for player 1, you have to be looking at when given the player 2's and player 3 strategies, what would be the optimal strategy of player 1, whether it is up or down. For that, first let's assume player 2 is going with the strategy left and player 3 is going with table 1. Then player 1 has choices to make between up and down, which means 3 and 2 would be the payoffs. So when you're comparing 3 and 2, obviously 3 is a better payoff. So mark it. And similarly, given the player 2 strategy is right and player 3 strategy is table 1, the payoffs for player 1 going for up would be 4, going for strategy down would be 5. So 5 is a better payoff, mark it. And it's not that alone. You have to be looking at table 2 also, because player 3 can also go with table 2 strategy. So if player 1, player 2 is given left strategy and player 3 strategy is given as table 2, player 1 has a choice to make again between up and down. So compare the payoffs, 2 and 6. 6 is a better payoff, mark it. Correct? And if player 2 is going with the right strategy and table 2 as player 3's strategy, player 1 again has choices to make between up and down. The optimal strategy would be up because it gives a better payoff than 3. Compared to 3, it's 4. So these are the optimal strategies for player 1. Similarly, you have to be looking for player 2 and player 3. If a particular payoff, if you're going to take this, so then it becomes the optimal strategies for all the 3 players. Then that would give us the Nash equilibrium. So let's see if there is any. And we are going to change the color so that it's less confusing. So now for player 2. So player 2 here, given the strategy of player 1 and player 3, how player 2 is going to be choosing between left and right. So for example, if player 1 strategy is up, player 3 ka strategy is table 1, player 2 can choose between left and right. Left and right, either 2 or 1, 6 or 4. So then if it is 2 or 1, obviously 2 is a better payoff, mark it. 6 or 4, 6 is a better payoff, mark it. Correct? But this is only when player 3 is going with table 1 strategy. But what if he is going with table 2 strategy? So coming here, player 1 up, player 3, table 2. Player 2 can choose between 3 and 5, left and right. 3 and 5, 4 and 3. Obviously 3 and 5. 5 is a better payoff, mark it. 4 and 3. 4 is a better payoff, mark it. So these are the optimal strategies for player 2 given the strategies of player 1 and player 3. So now going with player 3. So for finding player 3's optimal strategy, you have to be fixing player 1 and player 2 strategy. So if player 1 strategy is up, player 2 strategy is left, then up, left, up, left. So he can be choosing between this and this, table 1 or table 2. 5 and 4, so it's 5. Correct? So then it's 3, 2, 5. So all of their optimal strategies are being this. Then this point is called Nash equilibrium. But since in the question it is asked as strategy profiles is or, then there can be more than one point. So we have to be checking if there is any more where there is Nash equilibrium that you can achieve. So for which, let's continue finding the optimal strategies for player 3. So in that case, so this is only thing that is being done, then change the strategy. So now player 1's strategy is down, player 2 strategy is left, player 3 can choose between table 1 and table 2. So 1, 0. So 1. Correct? Similarly, now player 2 is changing the strategy. Player 2 is going with right, player 1 is with up. Then player 3 can choose between table 1 and table 2, which means it has to select between 3 or 7. So, or 7. And when player 1 is having down as strategy and player 2 as a right, player 3 can choose between table 1 and table 2, which is 6 or 3. So 6 is a better payoff, so mark it. So here if you're going to look at it, for here none of them have optimal strategies. Here player 1 does not. Here player 2 does not have the optimal strategy. Here none of them have the optimal strategy. Here player 3 does not have. Here none of them. So remaining points is where all three of them are having the optimal strategies. So then what are their respective strategies? So for player 1 it is up, right? Up. So we'll go back to red. For player 2 it is left. And for player 3 it is table 1. So that is one equilibrium. Another one that's been here is again player 1's optimal strategy here is up. Player 2 is right and player 3 is table 2. So you have to check in the question whether you have both of this or any one of this. So going back, up left table 1 hai, mark it. Down, no, there is no down optimal strategy for player 1 in the part of the Nash equilibrium. So cancel them. Up right table 2, yes, you did get up right table 2, correct? This. So D. A and D, there are two strategy profiles which are at Nash equilibrium. So A and D is the answer, right? So that's about it. A and D. So thank you so much. Hope you had learned how to solve Nash equilibrium in case of 3 players with 2 strategies each. If you had, please do like, share and subscribe to our YouTube channel. Thank you very much.